Hello, welcome to this physics video. Today I am going to start a new chapter which is based on that of refraction. So let us to look over here, student. I am having this is a glass. If I will place inside of this ball pen, so you are observing that nothing is going to happen in it. Okay, there is no change in the ball pen. But if I will pour the water in this glass, so if I will fill it with the water, now I am going to place this ball pen in this water. So what you are observing? So you are observing that the part of ball pen which is inside, it is appeared to be that a little bit bent as compared to this part of ball pen which is outside of this glass. Okay, so there it is the bending of this ball pen immersed part, and what we are going to call this is as, so this is we are going to call it is as a refraction. Okay, so refraction is what? That it is bending of the light while it goes from one to another medium. Okay, now let us to look over here a new example. I have taken this is that empty glass. Okay, so there it is the bottom of this empty glass, and inside of this I am going to place a coin. Okay, so there I have placed a coin. So it is just posed as a object which is placed inside of this glass. Okay, so now student, there is air right now in the glass. Okay, if I will keep moving my camera away from the glass, so you will find that this coin, it disappears. Okay, so it disappears from this position of the camera. Now if I will fill over here this one with the water, so you will find that this coin will once again start to appear. Okay, there you can see that I haven't changed the position of the camera. Glass is at the same position, but over there still we are able to look over here that there is that coin. Okay, so it means that when we are going to fill it with the water, so appearing to us that the bottom of the glass, it raises up. Okay, thus actual depth it was more, but now which is due to of this water, it becomes very less. Okay, so why it had happened? Then let us to know over here about of this refraction. So for this purpose, student, as we have seen over there, we were having a container and we filled it with the water. So this is the level of the water. Okay, so new here you will find that above of this there is the air, and below of this line there is water. Okay, so this line we are going to say that it is going to separate air from water. Okay, so thus over here this line, student, we are going to call it is as interface. This is what? This is interface. Okay, so over here for simplified diagram, that I'm having a line which separates the two media. So this is XY line and this is said to be interface. Now above of this interface there will be one medium. Okay, so there it is, one of the medium above of it, and the another medium is going to be below of it. So medium number 2. Okay, so thus they are separated to each other by this line, and this line becomes then interface. Okay, now let us suppose over here a perpendicular on this interface. Okay, so here we have supposed that there is a perpendicular drawn at this point. Okay, so this point it is O point which we have taken over here. Okay, so this perpendicular which is drawn on this interface at point O, we are going to call it is as normal. Here it is as normal. Now a ray of light that it falls directly over this point O. Okay, so here it is the ray of light which is coming to fall on this point O. Okay, therefore this ray of light which is falling over here, it is said to be as incident ray. it is incident ray, and the angle at which it is going to fall, so this angle we are going to measure the angle between normal and incident ray. So this is angle of incidence. So when this ray of light it goes from one to another media, then it bends away from its actual path. So we will find over there that if the medium will not change, so the light will go straight. So this light will pass straight. But due to of the change in medium, this light it bends away from its actual path, and this bent ray it is said to be as a refracted ray. It is a refracted ray, and this angle with the normal formed by this refracted ray, this is angle of refraction, it is R. So R is there, which is angle of refraction. Okay, so thus this phenomena of bending of light, now look up over here. This light it was going from one medium to this medium number 2, so it is going to bend from its actual path. So this phenomena is said to be as refraction. It is refraction. So what is refraction? Phenomenon of bending of light when it goes from one to another media. So this is said to be refraction. Okay, so whenever refraction diagram you have to draw, so that time you need to show this diagram in that. Okay, now what the term regarding to refraction we come to know over here. Terms related to refraction. So first thing is there, student, that of interface. First we come to know about what is interface. Okay, thereafter second point. So interface means boundary, or either it is what, line which separates two media. Okay, so it is going to separate the two medium, so this is said to be interface. Second thing, so we are having over here, it is incident ray. So what is incident ray? The light ray which falls on the interface. Okay, so this is over there, that incident ray. Now the third thing is that refracted ray. So we are getting that the light which went on passing from one to another media. Okay, so what is happening over there? There is light going to bend from its actual path. So this bent ray, it is a refracted ray. Now the third thing is there, normal. What is this normal? So it is perpendicular drawn on interface at the point where incident ray falls. Okay, so it is over here that incident ray falls. Okay, so that point it is said to be so over there we are going to draw a perpendicular, and this is normal. Just to check over here, that's point, this incident ray is going to fall, and we have drawn a perpendicular at this point, so this point it becomes then normal. Okay, And one more thing that which is our demand, student, this how do we represent light? Okay, light. Okay, so as we are known over there that the light which is coming from the sun, so how will you show this light? So important to note it down. So this light is represented with the help of ray. Remember that. How do we represent the light? It is with the help of ray. And that ray is what? So it is drawn in single arrow drawn in direction of light. Direction of light. So this is over there that ray. Now just to look this one, it is arrow, and this arrow is having its head, and there it is having its tail. So tail will give us its initial, from where it is going to come. So this initial point it is given by the tail, while this head will give us direction of light. Okay, so this is given by its arrow head. Okay, and if we are taking over there, student, there are more than one ray. For example, we are saying that these are the parallel rays which are traveling in the same direction, so it is said to be beam of light. It is beam of light. Okay, now the important thing over here, that while this light is going from one to another medium, there is bending of the light. Now why there is this bending of the light? So we can say over there, this bending of light, the reason behind of this, it is refraction. What that cause of refraction is due to change in speed of light. Okay, so why there is this refraction? So refraction is caused due to change in speed of light. Okay, so due to of this, that refraction is going to be caused. As next thing that we should learn over here. So why there is the change in speed of light? So the reason behind of this, student, that it is due to optical densities. Optical densities of different medium is different. Different medium is different. Therefore this speed is going to, therefore speed of light changes. Okay, so that is the important point, why there is a change in speed. So we can see over there it is due to the that change in this optical densities, and because of this there is the change in speed of light. Now student, over here that we are talking itself about medium. Okay, we are talking itself about medium. Okay, so we are having the two type of the medium. Here we are going to discuss it is of about two type of medium. So there the first type of the medium, student, which we are going to discuss, that it may happen over there that speed of light decreases. Speed of light decreases after refraction. Okay, so what we said over there is a type of medium in which speed of light will decrease after refraction, and over there there is this another type of medium in which speed of light increases after refraction. Increases after refraction. So this is that a second type of medium which we are supposing. Okay, now let us look at it with the help of this diagram, student. Now before of this, that if the speed of light will decrease, so this light will bend toward the normal. Next point I'm going to call the medium that in which the speed of light decreases, the light bends towards normal. towards normal. And while in this second type of medium, here the light speed is going to increase, so therefore here the light, it will bends away from the normal. Okay, so thus we come to know over here that we are having two type of the medium. In one, there is the speed of light is going to decrease after refraction, so the light will bend toward the normal, while in the other, this speed of light will increase after refraction, so therefore this will bend away from the normal. So let us to check it with the help of the diagram. Here we are having, this is the interface, here it is the normal drawn by us, interface it is xy, and this the ray is going to fall over here, and we are going to call it is as incident ray. So this is going to fall at an angle with the normal. So this is normal over here, and it is going to fall at an angle with the normal. Now after refraction, it is going to bend towards the normal because its speed decreases. So here it is going to bend toward the normal. So this is angle of refraction, and this ray, it is refracted ray. It is refracted ray, and while this was over here incident ray. Now just to check over here that what has happened, there is this medium number 1. This was medium number 1 and it was medium number 2. So check that light was coming from medium number 1 and it is traveling to medium number 2. So this refracted ray, already it is said that that in this medium there are the certain medium in which this light speed will decrease. Okay, so that means if v1 is the speed in this first medium, if v1 is the speed in first medium and v2 is the speed of light in second medium, so we get that v1 is greater than v2. Okay, v1 is greater than v2, and similarly over there, this angle of incidence is greater than angle of refraction, because you are finding over here this angle is greater as compared to this angle, because toward the normal it is going to bend. Okay, so such type of medium, what we are going to call them as, okay, so in which that light will bend toward the normal, so student, we are going to call them as that denser medium. They are said to be denser medium. Okay, so it is important to note what is denser medium. The medium in which speed of light decreases after refraction and the light will bend toward the normal. So this is the ray diagram for this one, and next is there that here that speed of light is going to increase after refraction. Okay, so now let us draw this diagram as well. Here we are having, this is that interface xy, and while we are going to draw, this is the perpendicular, and over there this ray is going to fall. It is the incident ray. Okay, it is the incident ray. So here it is going to fall on that point on the interface. Okay, so this was medium number 1 above this xy line, and below of this there is medium number 2. Okay, there is medium number 2. So this ray of light, it is going to fall, so this is incidence angle. And now if I will suppose that here this light is going to come with the v1 speed, so while it is going in another medium, so it went away from the normal. Here it went away from the normal. Okay, so what has happened over here? So we are looking that this angle with the normal, it is going to increase. So there it is, angle of refraction. Okay, and we are looking over here, there's a speed, we are having this speed in the medium, it is v2. Here I have said it is v2. Okay, so therefore which speed is greater? v2 is greater than v1. And which angle is greater? So you will find over there incidence angle is smaller than that of refraction angle. Okay, so such type of medium in which the light is bending away from the normal, okay, we are going to call those material or those medium as rarer medium. These are said to be rarer medium. Okay, so thus we come to know over here about two types of the medium, student. One, it is that of rarer medium, another it is of denser medium. So with the help of diagram we can understand them. If toward bending, normal there is, and normal say away bending hoti hai, so that time it becomes rarer. Okay, so here you can say that this medium number one, it will be denser medium. It is denser medium. Medium number one is denser. Why it is denser? Because that second medium in which the light is traveling, it is going to be rarer. So therefore this is rarer medium. Similarly over here, this second medium in which the light bent, it was denser medium. And while that in which the light was coming, it was rarer medium. Okay, so thus we are having over here, it is rarer and denser medium. Okay, now let us to check over here, student, as we are supposing that air medium, the light is going to travel with the 3 into 10 cube power 8 meter per second. It is the light speed in air medium. While over there in water medium, this light speed, it is going to be that of 2.25 into 10 cube power 8 meter per second. And in glass, this speed of light, it becomes 2 into 10 cube power 8 meter per second. Okay, so now if I'm going to take any two medium from these uh, written values over here. Okay, so let us suppose that here I'm having this interface, it is xy. Above of it there is air medium, and below of it there is water medium. Okay, and here I have drawn a perpendicular on this interface. This is said to be normal. Now student, the ray of light, it is going to fall in the this air medium. Okay, so here it is incidence angle. Remember that arrow is always indicating the direction, so it is indicating that it is going to fall on that surface. It is incident ray. Now will you suggest me this ray, when it will go in the water medium, so which side it will go? It will be away from the normal or towards the normal? Okay, so therefore what we said that if bending of the light will be toward the normal, it means that the speed of the light have decreased. Okay, so just to check that in air, light speed, it was 3 into 10 to the power 8. What in water, how much it will be? It is 2.25. It means it is going to decrease. If it is going to decrease, then this light will bend towards the normal. Okay, so here it will bend toward the normal, and this is angle of refraction. Okay, so it means to say that this water is going to act as denser media, and this air is going to be as rarer medium. Okay, now the next that we are taking over here, let us to suppose that I'm having here, it is water medium, and this next one, it is that of glass medium. Okay, so these two media are going to be separated by this boundary xy interface, which we are going to call. Now we are going to draw a perpendicular on this one, so that is said to be normal. Okay, now with this normal, a ray is going to incident on it. There is a ray which makes an angle with it, so this is incident ray with the normal, it is going to form an angle. Now will you tell me that in which that well, this light is going from water to glass, so it will bend toward the normal or it will go away from the normal? Okay, so for this, whether it will come toward the normal or away from the normal, we should to know over there that speed is increasing or decreasing. Okay, so check over there that in water speed was 2.25 into 10 to the power 8, and in glass it is 2 into 10 to the power 8. So 10 to the power 8 is same in both the case, but over there 2.25 it is in water, while in glass it is only 2. Okay, so it means that this water is having more speed as compared to that speed of light in glass. So it means that light speed is going to decrease. So if it is going to decrease, then student, it will bend toward the normal. here it is bent toward the normal, and thus we are going to say that this glass, what type of medium it is? It is denser medium. What type of medium is this? Denser. While this water is going to be as rarer medium. Okay, it is not necessary that always that upper medium will be the rarer and lower will be the denser. Okay, so that we can have the different scenario. You can check this one. This is the interface. Above of this you can suppose there is this glass medium, and below of this you can suppose there is the air. Okay, so here it is the normal drawn on this interface, and the ray of light is going to fall at an angle with it. So this is the angle of incidence. Okay, now tell me that when this light will go from glass to air, will its speed decreasing or it will increase? So as we are known with our these values that in air its speed is going to be higher as compared to that of water, so, or that of glass. So it means this will increase, and so the light will bend away from the normal. Here this is the bending away from the normal. Okay, so therefore air is what type of medium? It is rarer medium. It is rarer, while this glass it is going to be as denser medium. Okay, so that's over here in this video, student, we come to know about of this refraction. What is refraction and the type of medium? Important to note down this diagram, because mostly we are going to deal with only this diagram. So stay tuned, keep on watching. Thank you.